Alrighty, howdy everybody. We're on to our last video here. I know you guys are so excited for the last one. It's the last one of here 2020. So let's go ahead and jump in on there for everybody including me. So I'm excited for that aspect of it as well. I'm not going to lie. So ladies and gentlemen, let's go ahead and jump into this example. So it says, if so, are these congruent? So let's get some labeling here. So DE and EH. So DE and EH are the same. Then we got G, H, and DF. There we go. And then we're going to go ahead and take a look at F and G. Alrighty. So, ladies and gentlemen, boys and girls, if we look at all the different ways, we're looking at a side, and an angle. So our options are only going to be SAS, because if I do this, that's the same thing as doing that, and that's not going to work for anybody. So basically, we have this option. We don't have enough angle information. That's not a thing. So we're down to two choices here. So for it to be SAS, remember it needs to touch both angles. So this is, touch both sides. So this is one side and this is one side, no angle there. This is one side, no angle there. So this one's going to be not enough information to hang. Alrighty. So on this next one is you're going to go ahead and draw these two triangles. So I'm going to go G, H, I, and then we're going to do E, F, D. And then it gives you three pieces of information. So this one's going to work. So let's go ahead and start with one that doesn't work here so we can show you what's going down. So we have 2, 3, and 5. So we're going to have H and F, then I and D, and then GI, and then we have ED. So as we look at this, this one is going to be two angles and a side. So this is going to be angle, angle, side. And since that says it cannot work, that, like I said, this one doesn't work to satisfy our problem because it actually is a working scenario. So let's go ahead and erase all this. So I'll bring my triangles back and I'll show you why this one doesn't work, because it says it cannot actually work. So I'll erase these. So 5, 4, and 2. So H and F again, then GH and EF, and then we have GI, and then we have ED. So as we can see here, ladies and gents, it goes angle, side, side, because the in-between angle would be this one right here, and it's not there. So that means that this is trying to be angle, side, side, which is not going to work. So that's why that one doesn't work. All right, 43. So let's label. So it says GEA and LOD. So GAE and LOD are the same. Then we have AE and DO, and we need to prove by sassafras. So this is our angle right here, and so that's going to have the one that's going to need to have the sides on either side. So that pretty much tells us that it's going to be AG and LO. So AG and LO is going to be B. All right, moving on to this next one. So angle, angle, side is the kicker here. Notice that this side only touches one angle. So if we look at all of our pieces of information, let's look at one that does work and one that doesn't work. So this is angle, angle, so that's one angle, and then side, 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 side. So again, we've already said that that one doesn't work. You with me? So this one's going to be, if we look at this one here, C, those are our angles, another angle, and then the side in between, that's the side in between. So this one is going to be angle, side, angle, but not what we're looking for. So that means our answer has to be B here, because it goes angle, and then angle here, and angle here, and then the side only touches one of my angle marks. Alrighty. So our next one here is going to be a proof. So like we've done in previous proofs, you might as well just do the proofs and then see what comes up with it. So first it says that Q is the midpoint. Anytime you see something like midpoint, be prepared that you're going to have to use that. So I'm going to go ahead and label that this is a midpoint right here. And then I know that MQP and NQP are the same. So we have our given, check. And then it says we have our saying that they're midpoints. Well, if it's a midpoint, because it says definition of midpoint, let's put that MQ is the same as QN. So if we look at that, that's going to say basically that one right there. So we have boom shakalaka, boom shakalaka. Then every once in a while, proofs will do this. Well, they'll put givens. They won't put it all at the beginning. They'll mix it up. That's totally okay. I'm a huge fan of putting all my givens at the beginning, but that's just me. So then they share this side, and so anytime you share a side, we call that reflexive, and obviously that's what we have right here. So if we look at all of our choices of side, 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 sassafras, angle, side, angle, 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 side, and HL, I can cross out HL right off the bat because these are angle arcs, they're not right angles, and side, side, sides because I have no information right there. So if I look, I have been given two side pieces of information and an angle, so this has to be sass-e-frass. So we'll put a sass right there, and then we'll circle C for our correct answer. Alrighty, ladies and gentlemen, moving on to 47. So we got a lot of stuff going on here on 47. You can see a lot of different triangles, which means there's a lot of different ways to do this example. I'm just going to show you one way in particular. So the first thing I'm going to do is obviously realize that our answer could be a decimal. It's not going to, I don't believe, in this example, but it could be. So then let's label. So FHI, so FHI is going to be 3x plus 11. And then we have FDI, so FDI is going to be 6x minus 31. Alrighty. Again, oodles and oodles and oodles a way to do any of these particular examples. The first thing I'm always going to do is if I have one 90-degree box, I'm going to highlight the fact that I'm definitely means I'm going to have more than that. Okay. Then, ladies and gentlemen, I'm going to highlight that this triangle right here in red, because we have a tick mark right here and a tick mark right here, means that it's isosceles. So I can say that 6x minus 31 is equal to 3x plus 11, because these angles right here are my base angles. So I'll go ahead and move this 3x over, move that to the other side, then we get 3x is equal to 42. So x is going to be 14, I believe. Let me double check there. Double check my math here. So 42 divided by 3. Alrighty. So we have our 14 there. What unfortunately we're looking for is the value of y. We are looking at a 14 right here that's trying to distract us here, but we got to find out what y is. Alrighty. So what I'm going to do is I'm going to use that same isosceles sort of concept. We'll use the fact that we know that x is going to be 14. This big pink triangle right here is also going to be isosceles, and that these base angles are the same, so that means this is going to be y as well. So if I just highlight this triangle right here, I notice that we have 6x minus 31 plus a 90-degree angle plus y is equal to 180. I know x is 14, so I'm going to plug that in. And now we're just off to the races, going ahead and solving. So 6 times 14, 6 times 14. So that's going to be 74, 84. Minus 31 plus 90 is equal to y. Oh, sorry, plus y is equal to 180. And then when I bring everything to the other side, I'm going to go ahead and get y is equal to 37. Alrighty. Love that example. That's a good one. So, ladies and gents, in our next one, we're trying to prove because of this by hypotenuse angle. So, in this case, it's one of our another pieces that you can use. So, it says, what do we need to prove that these work? So, let's look at our situations. So, let's look at one that doesn't work. So, this is ln, and then we have xz, and then we have L and X. So we already have that is the kicker right there. That's not enough information for this to work, so that's why this one's not going to work. And our answer that is going to work is D. So let's investigate why. So MN and then YZ, you have your hypo, and then you're going to have M and Y. So that is our hypotenuse angle congruence. That's the only one that would make sense because I have my hypotenuse, I have an angle, and then it has to be a right angle. Booyah. All right, let's go to 49. So there's a couple of different things that can go on with this. And so the first thing I want to do is I want to talk about this pink triangle and then this purple triangle in terms of just because one's isosceles and one's equilateral, and we have some vertical angles, doesn't mean necessarily that they're the same size. So obviously, because all these are the same, this is going to be equilateral, and thus it's going to be equiangular, so all these are 60. So that means this, because these are vertical angles, this is 60. And thus, because it's a isosceles triangle, then these have to be 60 as well, because these two base angles have to be the same. So we have two now equilateral triangles, okay? So we now know that all the sides are the same and all the angles are the same. But again, I don't know that if this purple triangle and this pink triangle over here are the exact same size, just because the angles are the same. So, are they both equilateral? Well, we've definitely proved that. Are they congruent? We have not enough information to prove that because there's no angle-angle congruence, and so that's why that's a no. So TR is the same as QR. Again, that's the kickers. We don't know if those sides are the same. So not enough information. So RS and ST, that's all part of this triangle over here, so that's actually okay. And then all the angles are the same, so we're going to go ahead and say that PQR and RST are the same. Sorry, SRT. Alrighty. So, ladies and gentlemen, boys and girls, we're going to go ahead and move on to our next one, which is a proof. So it says that AB is congruent to AC, and we know that 1 and 2 are the same. So we are going to try to prove that these lines are parallel. So if I'm going to go ahead and prove that these two lines are parallel, it would kind of make sense that the 1 and the 3 are kind of leading us that that's the transversal I want to use. So I want to prove at some point that 1 and 3 are corresponding angles because they definitely look like it. Well, I can't quite get us there, but I can start with that 2 and 3 are going to be the same because this triangle here, I'll do it in yellow, is an isosceles triangle because of the tick marks they're given. So that means these two angles have to be the same because they're base angles of isosceles triangles, or a base angle theorem, which is what we see down here. Alrighty, so ladies and gents, 51, this is one of those where since they give us a lot of extra room at the beginning of your final or graph paper, this is so much easier to do when you see it on graph paper. So we're going to cruise all the way to the front of this where I see some extra graph paper. And we're going to do this one really quickly because you can kind of see what's going down. A lot easier when it's actually on a coordinate plane. You could definitely do this by hand, but it's so much easier on a coordinate plane. So the points were A, was 2, 3. B was 4, 8. And C was 7, 1. So let's go ahead and put those. So 2, 3, there's A. B is going to be 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7, 8. Let me make sure 1, 2, 3, 4, 5, 6, 7, 8. I keep having a horrible time. 1, 2, 3, 4, 5, 6, 7, 8. There we go. There's B. And then 7, 1, 2, 3, 4, 5, 6, 7, 1. So here's our triangle. And clearly, if we look at this, we have our first choice of either right or obtuse. Now, my gut is that I don't see any way there could be an obtuse angle right there. Sorry about that. Nothing like hitting the power button, which is what I did. So that screwed up the whole recording, so I apologize. But as I was mentioning, there's no way it's obtuse. It has to be right. So let's prove it. So for its right, it's going to be perpendicular. That means I'm going to have opposite reciprocal slopes. So let's find our slope here. So I go up 1, 2, 3, 4, 5 over 2. So it's rise over run. So let's look over here. I'm going down 2 over 5. So this is minus 2 over 5. So you could clearly see that these are opposite reciprocals. So even though it might not look like it, that is a right angle right there. So if it's a right angle, that also means, ladies and gentlemen, that this has got to be our vertex angle. So we have the next choice is isosceles or scalene. So I need to just prove that these two sides are the same. And I did that already because they have the same exact slope. Not even that it's the same number reduced. As I went up 5 over 2, down 2 over 5. So if I were to do the distance formula, these two sides would have to be the same. So it's going to be a right isosceles triangle. So I'm going to zoom out so I can go to the bottom much quicker here. And that's why this is going to be right isosceles. All right, last but not least, it says it's an equilateral triangle, and we have to find what this point is. And it looks like we don't have enough information to do that, but we actually do. And that is because since this is equilateral, all those sides are the same. Now, this bottom side is going to be the kicker because it's horizontal, so I can actually count. So notice that it's both 1 high, but it goes from 2 to 6. So that means each one of these sides are going to be 4 units. Alrighty. So, ladies and gentlemen, this point has got to be directly in the middle of our equilateral triangle. Okay? So, if I look what's in between the middle of 2 and 6. So, let's basically find the average of 2 and 6. So, I'm going to get 8 over 2, so that's going to be 4. So my x has to be 4 because it's the exact middle of 2 and 6. So then all I got to do is find what my y is, how tall it is. Now I can't say it's 4 tall because this side is 4. So what I'm going to do is I'm going to use the distance formula. So that's x2 minus x1 squared plus y2 minus y1 squared. I know that the distance, because it's an equilateral triangle, all sides are 4. And so now I just got to pick one point. So let's pick this 2, 1, because my numbers are smaller. So this is x1, y1. And then this is going to be x2, y2. And I already know that the x coordinate is 4. So this is going to turn up to 4 minus 2 squared plus, and then y2, which is what I'm looking for, minus 1, all that squared. So the first thing I'm going to do is I'm realizing that I'm solving for this y squared right there. So my friends, I'm going to go ahead and square both sides to get rid of the square root. So square, square. So this square root is going to cancel, and so I'm going to get 16 is equal to 4 minus 2, which is 2 squared, plus y minus 1 squared. I might as well just call it y, since that's what I'm looking for to make my life a little bit easier. So that's going to give me 4. So we have 4 plus y minus 1 squared. So I'm going to move this over and I'm going to get 12. So I'm going to stop here for just a second and just think about this really quickly. So let's think about numbers that are squared. So like y, if we think about it as 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. None of those numbers are 12. So that means that I'm going to have a decimal. But I'm also going to notice that that is going to be right here. So I'm going to need this to be somewhere in between 3 and 4. So that is a good way to estimate where you're going to be at, that we're going to be about 4.5, because I need to basically take this value and subtract 1. So that means our only answer is going to be D, because it's y minus 1 would be in between there. So I would add 1, which would actually move this to right there. So that's why it's 4.6. Now this is, you learned this in Algebra 1. This is how you're supposed to solve it, is because this is a squared, you're going to take the square root of both sides. So I'm going to get the square root of 12. So let's find out what that is. So square root of 12 is going to be 3.4. And that's equal to, and that's a plus or a minus, y minus 1. Move the 1 over, so I get 1 plus or minus. And so if I do the minus, I'm going to get a negative answer, and we can't have a negative because clearly it's a positive. So then we would say, alrighty, what is 1 plus 3.46? 4.46, which is y. That is our answer. Boom, there you go. So ladies and gentlemen, that is how we do this. Hopefully it's been helpful. Hopefully you found these videos to fill in all the gaps that you have, and you're now ready for your final. Wish you the best of luck. Let me know if you need any more assistance.